So hello and welcome to another video from PyNet Labs. So today in this video, we are about to discuss about VLANs. So basically we already had a session with VLAN. So we already recorded a video regarding the VLAN. So if you recall, VLAN stands for Virtual Local Area Network. Now, in simple terms, this is a logical segregation of a physical network. So suppose if I have a switch over here, consider like this is my switch, and say I have some PCs connected to it. Okay, so these are some of my PCs that I have connected. Okay, and consider I have some servers. Now, in order to separate these servers from the rest of the PC, what I do, I generally create a VLAN.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So we already had a session. We already discussed about VLAN. So I believe like most of us do already know about VLANs, right? So specifically in today's session, we are mostly focusing in voice or data VLAN. So we are going to look into what is known as voice VLAN and what is known as data VLAN. Okay. So in today's network, network segregation is a very big topic. So nowadays, if we want to keep our network organized, we always rely on network segregation. Okay, so what you do, you isolate mostly your devices into various groups so that you can easily manage the data, or you can easily manage the policies that you are actually running on your devices. So basically, VLANs, if we talk about VLAN, you can have two types of VLAN. So the first one is something that is known as voice VLAN, and the other one is something that is known as data VLAN. So let's look into this. What are these two VLANs? So consider that on your switch, on your local area network, you have also connected some VoIP devices. So rather than just computers and servers, you also have some phones. You also have some VoIP phones. Now, if you don't know, VoIP stands for Voice over Internet Protocol. It's kind of like the internet calling that we are doing, right? So rather than calling with our telephone network, we are actually relying on internet to make our calls. So when you actually communicate using VoIP, so that is known as Voice over Internet Protocol. And in order to better manage the VoIP traffic, we mostly refer to voice VLAN. So a voice VLAN could be a VLAN consisting of VoIP devices. Okay, so this is what is known as your voice VLAN. And if we talk about data VLAN, so it generally consists of our regular computer that you use. So whenever we are texting someone, whenever we are sending email someone, whenever we are browsing the internet, those all types of data, they come into a data VLAN. And whenever you are calling someone, whenever you are communicating with someone, so that type of network known as a voice VLAN. Now, I would like you to better understand this concept of voice or data VLAN. I would like you to consider an example. Suppose you are in a customer support team. Okay, so mostly you guys have noticed, like whenever we are thinking about customer support, so they have both. So they have the PCs as well, and they have the VoIP access as well. So they have their intercom through which they can actually communicate. So in order to differentiate the data that is coming from a PC or from the VoIP, we always create two types of VLAN. So all your VLANs, all your devices, all your PCs might be a part of a particular VLAN, and all your VoIP data could be in another VLAN. Okay, so the benefit of creating different VLAN is that you can actually prioritize which data that you want the most. So in order to make our communication a little bit better, what you can do, you can actually prioritize what kind of communication you want to have. Okay, and in order to prioritize that type of communication, we always rely on VLAN. So VLAN helps us in prioritizing network. So you are separating the voice data from your computer data so that you can process it faster, and so that you can send it to the destination way more faster than your normal data. Okay, so when we actually working with voice VLAN, when you actually create a voice VLAN, so first of all, you separate the voice data. So you separate your voice data from the rest of the traffic. So your voice data or the things that you are communicating doesn't get intermingled with your LAN data or with the data that the computers might be sending. Okay, so it separates your voice data, and also later something you can also put on something that is known as quality of settings. Okay, or quality of service. So you can actually enable quality of service here. So basically, quality of service means that uh, we are just prioritizing the data. We are prioritizing the voice data over our uh, normal computer data. So in that way, you actually helps us in increasing the communication effectiveness. So whenever we are calling with voice, we don't want we wouldn't like when our calls drop, when our voice drops, when you are unable to hear the other person who is speaking on the phone. So in order to make sure that your voice is actually reaching to your destination, is actually reaching to your clients, or actually reaching to your customers, you actually implement voice VLAN. Okay, so voice VLAN essentially helps you in segregating all those voice data into a separate network, and that way you can route it way more faster than your actual data. So a well-designed VLAN can actually enhance the capacity of your network. A well-designed VLAN or a well-designed, thought-out VLAN or a well critically thinked or processed network can actually help you processing the voice data much better. So wherever you are using VoIP, so it's recommended that we always go for the configuration of data VLAN and voice VLAN. So we already covered up how we create a VLAN. So let me show you how we can actually, let's just recall how do we create a VLAN. So in order to understand how voice or data VLAN works, I have just created a network here, as you can see on your screen, on your screen here. So here I have just created two VLAN. So on the left side, we have all the VoIP phones connected. So as you can see, I have all the IP phones here connected. So these are not your regular telephones, they are the IP phones. So they work on the basis of IP address. And on the right side, we have our computer. So if you look over here on the right side in the blue box, we have our computer. And all these devices, all these 8 devices are connected to a single switch, as you can see here. And basically, what I want as a network engineer, in order to make optimize my network, I would very much like to separate these different devices apart. Okay, so I want to keep this VoIP phones on one side of the network, and I want the computers over here on the other side of the network. And I don't want that both of them to share data, and I don't want the data coming from VoIP network to be intermingled or get mixed up with my computer data. So in order to do that, first of all, we will gain access to this switch. So here I am on my switch interface, and I just received some notifications since we have just connected few of the devices. I'm going into the privilege mode, and I'm going into the configuration mode. And just to make sure that I can easily identify my switch, I'm changing my switch name. So this is, let's say, I'm going to keep it as network 1, or let's say simply net 1. So this is my switch name. Okay, and here I'm going to create two VLAN. So if we look onto the VLAN configuration, we can clearly see that we don't have a VLAN yet. Okay, so I'm going to create two VLANs. So first VLAN is going to be VLAN 10, and I'm going to name it as voice VLAN. So as you guys have guessed, this VLAN is going to be for my VoIP phones. And similarly, I'm going to create another VLAN with the name data VLAN. And once again, this VLAN is going to be for my computers. So I'm done with the VLAN configuration. If you look over to the VLAN database, you can very much see like we have the VLANs created. So here you can see we have the data VLAN and the voice VLAN. So now I would like to, with that, I'm actually saving the configuration that I made to my switch. So I'm saving this configuration, and let's get back to the topology once more. And here, as you can see, these are some of the interfaces that I'm using. So let's see what are the interfaces that we are using in order to connect the VoIP phones. So here, this is FA1, here this is FA2, and here this is FA3. and here there is FF4. So from fast Ethernet 1 to fast Ethernet 4, I'm going to assign these interfaces to the voice VLAN that we have just created. And in order to do that, we are once again going back to the switch here, and I am following some commands. Okay, so here I'm going to select the range of the interface. So the range was from fast Ethernet 0 by 1 all the way to 4. Okay, and I am going to configure these port as my voice ports. Okay, and I'm going to assign them to VLAN 10. All right, and I'm going to exit from here. So we are done here. Let's see. Let's check our VLAN configuration. So if you notice here that on my voice VLAN, I have successfully assigned the 4 interfaces, and just like that, I'm going to save this configuration. And once again, we are going back to the topology. So if you go back to the topology, so you can see like these ports are right now processing. So once they are gone through the processing, they will turn green. That means my devices are ready to use. Now what I'm going to do, I'm going to add all these pieces together in another VLAN that is known as the data VLAN. So in order to do so, first of all, I have to get the idea like which interfaces these devices are connected: FF5, FS6, FS7, and fast Ethernet 0. All right. So I just got the information like in which ports my devices are connected. Now I'm going once again going to select all of these devices, all of those interfaces, interface range from fast Ethernet 5 all the way to 8, right? And I'm going to assign them to VLAN 20 here. That's it. Now, if I check here, do show VLAN brief with the command, the VLAN database. So here you can see like both of my VLAN, the voice VLAN and data VLAN has been populated. These two VLANs are active. And currently we can see interface from 1 to 4, they belong to the voice VLAN. And the VLAN from fast Ethernet 5 to 8 belongs to the data VLAN. So this is how you actually configure a voice VLAN and data VLAN in your network. So in this way, what you can do, you can maintain higher or prioritize the voice data over your regular computer data. In that way, you can gradually increase your network's output or your network's performance. And from the perspective of network engineer, these things are very much important. So that's all about today's video. So if you guys would like to ask something, I would highly encourage you that you follow the comments option. And in case if you want to see any other topics, if you want to see how VoIP devices works, how voice VLANs works, or how the whole communication process works, don't forget to mention it in the comments. So thank you everyone. See you in the next video.